Okay, in this lesson I'm just going to define and work with what is known as average acceleration. So the average acceleration is defined as the change in velocity divided by the change in time. Remember, average velocity was defined as the displacement divided by the change in time, and displacement is defined as change in position. These are things we have to get into our heads for it to be able to solve problems at this level. Remember, we said the Greek letter delta means a change in something, so change in velocity, delta v, change in time, delta t, and just a bar on top of a letter means average, so a bar there is what we would call that. A bar is average acceleration. Okay, so average acceleration. So I'm going to just go through a few scenarios where we're given information and see if we can work out average acceleration or some related quantity in each case. So my initial velocity is 3 meters per second. 6 seconds later my velocity is 15 meters per second. What is my average acceleration? Well, average acceleration, let me run through my little definition first. We know our average acceleration by our definition is change in velocity over change in time. Of course, you've got to be able to change the subject of the formula. We could say the change in time is the change in velocity divided by the average acceleration. And I could also say the change in velocity is the average acceleration multiplied by the change in time. So I have to essentially choose one version of the formula. What am I looking for? Well, I'm looking for average acceleration. Average acceleration is change in velocity over change in time. Change in velocity is final velocity. Subtract initial velocity. Remember, change in any variable is the final value for that variable minus the initial value for that variable. So change in velocity is going to be my final velocity, which is 15 meters per second. Subtract my initial velocity, which is 3 meters per second. Divided by my change of time, which is actually given as 6 seconds. So what we get there is 15 subtract 3, that's 12. The units here, it's meters per second divided by seconds. So you might see that written as meters per second per second. More usually you'd see it written as 12 meters per second squared. Okay, so my average acceleration there is 12 meters per second squared, or 12 meters per second per second. Okay. My initial velocity is 3 meters per second. 6 seconds later, my velocity is negative 15 meters per second. What's my average acceleration? Average acceleration is defined as being change in velocity over change in time. So in this case, my average acceleration is going to be change in velocity when my final velocity is negative 15 meters per second. Subtract my initial velocity, which is positive 3 meters per second. And that's divided by my change in time, which is 6 seconds. So what I'm going to have here is negative 18 meters per second divided by 6 seconds, which gives me negative 3 meters per second squared. Okay? Positive velocity, negative velocity, what does that mean? Well, that means the object has turned around at some stage through 180 degrees. So it's maybe if it's a right positive system, initially it's moving right at 3 meters per second, and then at the end it's moving to the left. That's what the negative sign in there would mean left. Why left? Because it's a right positive system. This means it's moving right at 3 meters per second. So it starts moving to the right at 3 meters per second. At the end it's moving to the left at 15 meters per second. The average acceleration in that case is negative 3 meters per second per second. So on average, every second, its velocity is being reduced by 3 meters per second. My initial velocity is 3 meters per second. I travel for 6 seconds with an average acceleration of 7 meters per second. What is my final velocity? So I'm trying to find my final velocity. One thing I might try to find first for my formula is change in velocity. We can see is average acceleration multiplied by change in time. So the first thing I'm going to do is look for my change in velocity here. So my change in velocity is going to be the average acceleration multiplied by the change of time. So average acceleration is given. My average acceleration here is 7 meters per second squared. and I'm multiplying that by my change in time, which is 6 seconds. So average acceleration 7 meters per second squared multiplied by change in time 6 seconds. 7 sixes, 42 meters per second squared multiplied by seconds. Well, that's just giving me meters per second. So my change in velocity is 42 meters per second. Notice that's positive. That means my velocity has increased by 42 meters per second. So my final velocity is always going to be my initial velocity plus my change in velocity, which is going to be 3 meters per second plus 42 meters per second, which is going to be 45 meters per second. So my final velocity is 45 meters per second. If I start traveling at 3 meters per second and then I have an average acceleration of 7 meters per second squared for 6 seconds, my final velocity will be 45 meters per second. An acceleration of 7 meters per second squared, an average means on average every second my velocity is increasing because it's positive by 7 meters per second. Okay, you could nearly count that up. If it's increasing every second, on average every second by 7, counting up for 3, after 1 second it will be at 10, after 2 seconds it will be at 17, after 3 seconds it will be at 24, after 4 seconds it will be at 31, after 5 seconds it will be at 38, after 6 seconds it will be at 45 meters per second. Initial velocity is 2I hat plus 3J hat meters per second. That means something traveling up to the right. Its I hat component and J hat component are changing. My final velocity is traveling at 11 I hat minus 15 J hat meters per second. So I've sped up, however, I'm now traveling to the right and kind of down on my coordinate system. We start off traveling in this direction, we finish off kind of traveling in this direction. I don't know really what happens between them. The other thing I should have put in a change in time, which I've left out of this question. Let me just stick it in here now. Let's just say the change in time is 3 seconds. Okay, and I want to find my average acceleration down here. That's my question. Average acceleration is defined as being change in velocity divided by change in time. So the first thing I'm going to have to figure out is what is the change in velocity. Well, the change in velocity is defined as being the final velocity subtract the initial velocity. The final velocity in this case is 11 I hat minus 15 J hat. And we're going to subtract the initial velocity, so subtracting all of 2I hat plus 3J hat. And when we're subtracting, there's two terms, we have to subtract the 2, but also subtract the 3 from the 15. 11 subtract 2, that'll give me 9I hat. Negative 15 subtract 3, well, that'll be minus 18J hat. So my change in velocity is 9I hat minus 18J hat. In other words, we've increased our I component by 9 and decreased our J component by 18. My average acceleration here is going to be my change in velocity, which is 9I hat, subtract 18J hat. The units here are meters per second. Divided by my change in time here, which is 3 seconds. And I've got to distribute this division across, so both of these terms have to be divided by 3 seconds. So 9I hat meters per second divided by 3, well, that's going to be 3I hat meters per second squared. Negative 18J hat meters per second divided by 3, well, that's negative 6, and the units again, meters per second divided by second, meters per second squared. So the average acceleration is 3I hat minus 6J hat, I left out the J hat in there, meters per second squared. That's the average acceleration over the course of these 3 seconds. So on average every second the I component of the velocity is increasing by 3 and the J component of the velocity is decreasing by 6 on average every second. And that is average acceleration. Okay, so try the quiz based on this, see how you get on.